When dividing fractions, we can apply the KCF method. K stands for keep. We keep the first fraction exactly the same. C stands for change. We change the divide into multiply. And F stands for flip. We flip the second fraction. When multiplying fractions, we just multiply the tops and multiply the bottoms separately. But before we do that, we must try factorising the top and the bottom of each fraction where possible. Looking at our first fraction, 3x plus 6, as I have two terms, we always try single brackets. The highest common factor in 3x and 6 is actually 3. We now open our single bracket. What do I times 3 to get back to 3x? We're missing x. What do I times 3 to get back to positive 6? I'm missing plus 2. On the bottom, as I have three terms, I've got a quadratic in terms of x. Therefore, I'm just going to factorise into what we call double brackets. As my quadratic starts x squared, each bracket starts with single x. I need to find two numbers that multiply to give us the number term, in this case negative 10, and the same numbers must still add to give us a number in front of the single letter, which in this case is negative 3. The only pair that multiply to give us negative 10 and add together to give us negative 3, in this case is going to be plus 2 and minus 5. Leaving the multiplication sign alone. Once again factorising the top and bottom where possible. On the top here, I can see x cubed and negative 25x. If you've got two terms, you always initially try single brackets. The highest common factor in x cubed and negative 25x is in fact x. If I then open my single bracket, what do I times x to get back to x cubed? Well, I'm missing x squared. And what do I times x to get back to negative 25x? I'm missing negative 25. But we should notice now on the inside, we've got something special, what we call difference of two squares. As we've got a squared term, subtract a squared term. Hence, leaving the single x on the outside for now. On the inside, I've got difference of two squares. I know that a squared minus b squared will factorise into double brackets of the form a plus b multiplied by a minus b. As I've got x squared minus 25, therefore I'm going to start by opening my double brackets. What multiplied by itself gives us x squared? Well, I know x and x. I know the square root of 25 would be plus 5 and minus 5. On the bottom, again, I've got two terms. I always try single brackets. As there's nothing common in x and positive 5, I can still place that inside a single bracket. I'm now going to check each fraction for any common factors. Look at my first fraction. I can see that both on the top and bottom, I've got in single brackets x plus 2, so I can cancel x plus 2 on the top and bottom. Look at my second fraction. I can see that both top and bottom have in single brackets x plus 5 in common, so I'm going to cancel that. Multiply whatever's now left on the tops. On the top here, I've got 3 multiplied by x, which will give us 3x, and it's still multiplied on top on single brackets of x minus 5. On the bottom, here I've got x minus 5. As this is cancelled, there's only thing left now is 1. X minus 5 times 1 is just going to give us x minus 5. Again, finally checking to see if I've got any common factors. Here I can see I've got x minus 5 common on both the top and the bottom. So I can cancel x minus 5 on the top and bottom. Hence, my final answer is just 3x.
Your turn.